Let's learn about constructors in Java. The question comes, what are constructors? Those who have already worked with C++ will be able to answer this question. Constructors are also functions, but they are special type of functions since they have the same name as that of the class. The second feature of constructors is they do not have any return type. Remember, when we studied functions, we told functions always have a return type. Example, int in case it returns an integer, and so on. If the function does not return anything, we write void. But in the case of constructors, there is no return type. That indicates there will be no void also present, since void is also a return type. The major use of constructors are used to initialize an object. We know object consists of various properties. To initialize the properties when we create an object, we make use of constructors. We have created a plain Java project and we named the project as Constructor. Within this, we have created a package with name com.qspawn.constructor. Within this package, we have created a class with name car. The car consists of number of wheels and number of doors, both of which are int, and also a color which is string. We know this all stands for properties of a particular car, which are also known as attributes. Now within this car class, we have a function with name public car. As we can see, this function, it doesn't have any return type, and the name of the function matches with that of the class, which indicates it's a constructor. Now within this constructor, I am initializing the values of number of wheels as 4, number of doors as 4, and color as red. Following down, we have methods like getColor, which returns me the color, as well as setColor, which sets the color. In a similar way, we have getNumberOfWheels as well as setNumberOfWheels, and we have getNumberOfDoors and setNumberOfDoors. These functions are capable of returning us the value of properties. Now to make use of this constructor, we have created a main class. Within this main class, we have created the object of car by using the new keyword. Now whenever we invoke this car constructor, the car constructor within this car class will be invoked, and the number of wheels will be made as 4, number of doors will be made as 4, and the color will be made as red. So when I say car.getColor, I will get the color as red, since the color has been made red within the constructor itself. So let's run this Java example, and as we can see, the output shows red, which indicates the color has been made red whenever we invoke this constructor. So in this way, constructor can be used to initialize the variables or initialize the attributes or properties of a particular class. Now this constructor is not dynamic, since we are not passing the values as parameters to this constructor. We are passing static values of 4, 4 and red within this constructor. Hence we cannot say this constructor as dynamic in nature. To make it more dynamic in nature, we can pass various values to this constructor just as parameters, which we used whenever we used functions. In a similar way, we can pass parameters which can be then used to initialize the values. The next question which comes is, what happens whenever constructors are not defined? It is quite possible a class may not contain constructor at all. At that time, what will happen whenever we invoke the new name of the class? So whenever you don't have a constructor in a particular class, Java creates a default constructor for you. This default constructor will be used till you don't define your own constructor. So let's try to understand how it creates a default constructor with the help of an example. As we can see, within the package com.qspawn.default constructor, again I have car as the class, but here as we can see, we don't have any constructor within it. We have other functions like get color, set color, but none of these functions have the same name as that of the class. And all these have some return types like string and void, which indicates they are not constructors. Now within the main function of this particular main class, which will actually invoke the car, we again say car equals new car. Now whenever we say car equals new car, and since car doesn't contain any constructor, Java automatically creates a default constructor for it. The default constructor will not initialize any value, which will be evident whenever we try to invoke the get color function. If you see this class, get color function returns us color. Now when I try to invoke the same within the Java application, it is returning me a null value, which indicates this value has not been initialized. So even though the object is created, the value of get color continues to be null. So whenever we don't define our own constructor, the Java provides us with a default constructor, but it will not initialize all the properties present within the particular class. The next question which comes is, what happens whenever we create our own constructor? Whenever we create our own constructor, whether the default constructor continues to stay or goes away? The answer to this question is, whenever we create our own constructor, the default constructor is removed. This is because default constructor was present whenever we didn't define any constructor at all. The moment we take the ability of creating constructor within our hands, Java does not have to create a default constructor for us, and hence the default constructor is removed whenever we create our own constructor. To understand the above concept, within this example, let's say we create a car constructor which takes int number of wheels. Now within this constructor, let's say we are making the number of wheels as equal to the number of wheels which we passed. Now as we can see, once we do this, within the main function we are getting an error saying that we are not using the car constructor, which is having one argument, and it says the constructor car is undefined. This is because whenever we created our own constructor, the default constructor is lost. As a result, the main function within this main class is given as an error. So in case we remove this, then there is no constructor in this particular class and the error will disappear. This indicates to us whenever we have our own constructor, the default constructor is lost. It is also possible to have more than one constructor within the same class. This is because within the same class we can have more than one function, but the function should be having difference in parameters or return type in case the names are same. So the similar concept can be applied to constructor, but since constructor don't have return type, they should differ in number of parameters. So again, in the car class, we see there are two constructors, both of them public in nature, both of them having no return type, and the number of wheels in the first constructor, which takes no parameters, is set to 4, 4 and red, while in the second constructor it takes number of wheels, number of doors and color as argument, and the properties of this particular class are set based upon the values which we passed within this constructor. So as we can see here, we have two car functions within the same car class, which is having no return type, which indicates they are constructors but differ in the number of parameters, which indicates there can be more than one constructor within the same class. This concept is known as constructor overloading. Now within the main class, whenever I invoke new car 88 green, it will go and invoke the second constructor since the arguments matches with it. So 8 number of wheels will be present, 8 number of doors will be present, as well as the color will become green. So when I say car.getColor, it will return the color green, indicating to us that the value has been set as per the second constructor which we passed. The next question which comes is, can a constructor be made private? Yes, a constructor can be made private, since within a class we can also have private functions, and constructors are nearly like functions, hence they can also be made private. But whenever we make a constructor as private, it cannot allow other classes to create its object. Since a private function cannot be invoked outside the class, hence a constructor which is marked private cannot create instance outside that particular class. This forms a very important property because this restricts any other class from invoking the constructor, which further stops other classes from creating the instances. This is helpful especially if the object created is very heavy in nature. A object is said to be heavy in case it occupies a lot of resources. So creation of objects should not be done at very much ease, and we want to restrict the end users from creating many objects of the same type, so we can make the constructor as private. This forms the backbone for a pattern with name singleton. We have created one more package with name com.QSpawn.private constructor, within which we have again the car class, but now we made the constructor as private. Since we made this constructor as private, no one outside this class can create this object. So within this particular class itself, we provide a getInstance method. The getInstance method is marked as static, which means to invoke this particular function, we need not create an object of this particular class. This function can be invoked by using the class name itself. And within the getInstance method, we create a new car object. Since getInstance is within this particular class, it can invoke this new car even though it is marked as private. Now within the main function, we use car.getInstance, which will invoke the call to the private constructor, and whenever we do getColor, it will return us the color red, since the color red is set within the private constructor of this particular class. So let's run this and see the corresponding output, which gives us red, which indicates to us that the getInstance method invoked this private constructor. So this indicates to us a constructor can be made private in case you don't want anyone else to create this object of this particular class other than a method within this class. We have seen what are constructors. Next, let's see how constructors will behave in inheritance scenario. This is also known as constructor chaining.